All right, your quiz, guys, tomorrow is 8 questions. I know you're like, what? It's only 8 questions. I mean, one of them is like this, so there's like a million things to do in one question. So I'm going to go over every single type of question that you're going to see. So pay attention to the ones that I'm doing. The other ones, use them as extra practice, but pay attention to the ones I'm doing. So in a question like number 1, where it's going to ask you for all of this stuff. Remember the domain, the range, all that good stuff. What can I put right away without even looking at the problem itself? What can I answer?
The y-intercept.
Okay, the y-intercept is what? 2. Okay, so we're going to write it as an ordered pair, so 0, 2. And what else can I answer on this list? The domain. What is your domain for every single one of these parabolas we're doing? Negative infinity to positive infinity. Okay, now we're going to look at the equation itself. We're going to put it in standard form so we don't make any silly mistakes. And we're going to draw ourselves a little picture so we can kind of answer some more things. If I were to write this in standard form, do you guys agree this is negative 3x squared minus x plus 2, correct? Okay, so what kind of a parabola is this, positive or negative? It's negative. Draw yourself a little picture so you know it's going downwards. That means a lot of things. What's our range? Is it negative infinity to the y part of the vertex? Or is it y part of the vertex to infinity? It's negative infinity, good, to the y part of the vertex. Whatever that y part is, and it's always going to include it. What letter do we use for axis of symmetry? X equals, good. Does this have a maximum or a minimum? Has a maximum, good, and it's going to be at what letter? Y equals. How do you find the intercepts? What are we going to do? Factor it. We're going to set equal to 0 and factor, good. And then vertex form, we'll talk about in a second, because what do you have to find in order to write something in vertex form? You got to find the vertex, okay? So let's do that. What's that tiny little formula to find the x part of the vertex? Negative b over 2a. Be careful with your signs, guys. You have a negative 1 over 2 times what? Negative 3, okay? So negative gives me a positive, and then 2 times negative 3 is negative 1/6. You're gonna have fractions tomorrow, I promise you. I'm not gonna have you graph it, but you're gonna have a fraction. So what do I do with that negative 1/6? I found the x part of my vertex. I'll write it down here. Look, vertex. Yep, negative 1/6. So I'm going to take that and plug it into the equation to find the y part.
Is there going to be like a graphing part?
No, not for this, no. So y equals negative 3 times negative 1 over 6 squared minus negative 1 over 6 plus 2. Everybody with me? Okay, now we're going to go back to middle school. Negative 3 over 1, right? What happens when I distribute this 2? It goes to the numerator and where? To the denominator. So negative 1 squared is 1. 6 squared is 36. Good. This is pretty simple here. I don't even have to multiply anything. Minus the negative is going to give me plus 1/6. And I have the whole number 2. I'm going to put it over a 1 to remind myself, oh, I got to get a common denominator at some point. So let's go ahead and simplify. If I simplify here? Negative 3 and 36. Can I simplify there? Okay. Negative 3 goes into 36 how many times? 12. And it's going to be negative, right? Because it's a negative out there. So I have negative 1/12 plus 1/6 plus 2 over 1. What's your common denominator going to be between all of these numbers, guys? Okay, 12. So I have this stays the same, negative 1. If I change my sixths to twelfths, I have to multiply by 2, right? What you do to the bottom, you do to the top, so it's plus 2. If I change 1 to twelfths, what you do to the bottom, you do to the top, so I have to multiply, and I get plus 24. That's probably the hardest part of this problem. It's just you guys being able to multiply fractions and add them. But now, what's negative 1 plus 2? 1 plus 24. So 25 over 12. That's the y part of your vertex. 25 over 12. Now we can answer almost everything else on this list.
The range.
Okay, the range, the 25 over 12 is going to go right here. What's my vertex? Negative 1 over 6 and 25 over 12. Good. What's your axis of symmetry? X equals negative 1/6. What's your maximum or minimum point? Y equals 25 over 12. Perfect. And let's do the vertex form. Our vertex form is going to be f of x equals, what is your a value? Negative 3. It's the number in front of x squared. Then I have x minus, what's the x part of your vertex? Negative 1/6. So minus the negative is going to be plus 1/6 squared. And then I put what? Plus 25 over 12. Now we have answered every single question on this list, except for x-intercepts, literally by looking at the equation and finding the vertex. Everything is dependent upon the vertex. Very, very important. Understand axis of symmetry, the x part of the vertex. Range and maximum minimum, the y part of the vertex. Now, how do we go about finding the x-intercepts? You set the equation equal to 0. So I'm going to take out the negative 1 because I don't like to factor with the negative. So I'm going to write this as 3x squared plus x minus 2 equals 0. Tomorrow, everything will factor. Going forward, after we do complex numbers, it may not. So multiply a times c, 3 times negative 2. So what are the factors of negative 2 that multiply to give you negative 2, but add to give you a positive 1? I'm sorry, negative 6. Multiply to give you negative 6, but add to give you a positive 1. Okay, minus 2 and plus 3. Now, guys, I factor differently than some of you may, and that's fine. My a term right here is not 1. So what I do with it is I put it underneath here, and I put it underneath here. And if it divides out pretty, great. If it doesn't, then it becomes a coefficient. So your negative 1's out here. Does 2 divide by 3 nice and pretty? No. So this becomes 3x minus 2. Does 3 divide by 3 nice and pretty? Yep. So this becomes x plus 1. Good. And now how do we find our intercepts? We set each little piece equal to 0. So negative 1 equals 0. Is that true ever? No. So 3x minus 2 equals 0. X plus 1 equals 0. So when I solve here, I move the 2 over, divide by 3. So x equals 2/3. And then x equals what? Negative 1. And how do we write intercepts, guys? As negative 1 comma 0. Good. Ordered pairs. Negative 1 comma 0 and 2/3 comma 0. I'm not having you guys graph.
Why did you multiply the 3 to the other equation?
You mean just move it to the front?
Yeah.
That's just how I factor when a is not 1. You can do it this way. You can say 3x squared plus x minus 2 equals 0 and use grouping. So you have 3 and negative 2, right? So 3x squared plus 3x minus 2x minus 2. And then group them. What do they have in common?
And
3x, so you're left with x plus 1. And then here, what do you have in common? Negative 2, x plus 1. So you have x plus 1, and then 3x minus 2. Same thing. Instead of factoring out the grouping by putting it in front, if you just take the a term and divide both of the factors that you get the same answer. Yes, ma'am?
Do you have to take out the negative 1? Or can you leave it?
No, you can leave it.
But then, do you get different x?
You have to make sure that you shouldn't. If you do the factoring correctly, you shouldn't. But that's why I like to take out the negative 1, then it doesn't mess up signs. All right, we're good with that. You got everybody in here will have one of those. So let's move along. Again, if I gave you something like this and I said, write it in vertex form, what do you have to find? The vertex, and then what is your a value? It's the number in front of x squared. Okay. Okay. And behaviors. There is going to be a question that looks just like this. You can answer it exactly how I'm showing you. You don't have to put anything on the answer lines as long as you guys are showing me your work and circling it and I can see it. What I mean by that. First thing you absolutely have to do, and I'm going to say this because I've worked out all 7 versions of the quiz, put the equation in standard form. Make sure the highest exponent is first. Is it? Yes. Okay, so we're good. So the highest exponent we have here is a what? It's a 4. What kind of a number is 4? Odd or even? So when I see even, I think of what about the arrows? Same. So talking about the end behaviors, we're talking about the ends of the graph. Is this a positive function or a negative one? Positive. That means both of the arrows are going in which direction? Up. So when I talk about end behaviors, here's the left-hand side, here's the right-hand side. What are the end behaviors? What is your graph doing? It's rising left, whoops, rising left, and rising right. That's all you have to do. If you write it on the line, great. If you don't, no big deal, just circle it. So now zeros, multiplicity, and action at the x-axis all go together. How do you find the zeros of a function? You set it equal to 0. 98% of the time, what does that mean we're going to have to do? Factor, okay? So when we factor, before you guys group it, what's the first thing you look for? Does it have a GCF? Is there something that they all have in common? Yes, what is it? X. Guys, what's the highest exponent you see? 4. How many answers should I get? 4, okay? So this leaves me with x squared. Sorry, this is cubed. X cubed minus 6x squared minus 2x plus 12. Agreed? Now that you have 4 terms, what do? We group, okay? What can I take out of my first set of parentheses? An x squared, okay, so x squared, and I'm left with x minus 6, okay. What can I take out of my second? A what? Negative 2, and I'm left with x minus 6, okay. So I have the x out in front. What's my new GCF? X minus 6, yes? Okay, and then what gets its own parenthesis? X squared minus 2 equals 0. Can you factor x squared minus 2 anymore? No, because 2 is not a perfect square. But you can still solve it. What do I do to find my zeros? I set each piece equal to what? To 0. So I have x equals 0. X minus 6 equals 0. X squared minus 2 equals 0. So is one of my zeros x equals 0? Yes. What's my second one? X equals 6. Okay. If I solve this, x squared equals 2, and then I do what? Take the square root. So x equals what? Plus or minus the square root of 2. Is that 2 different answers? Yes. There's all 4 of your answers right there. There's your 4 zeros, guys. So now these questions over here about multiplicity and all that stuff, you don't have to write it on the line. Do you have multiplicity? No. How many times do you have x equals 0? 1 time. How many times do you have x equals 6? 1 time. How many times do you have positive root 2 and negative root 2? 1 time. You can tell me the multiplicity by how many times you see an answer. If it's 1 time, there's no multiplicity. If it's 2 times, then yes, you have multiplicity. Now, what happens at the x-axis? If you have multiplicity an odd number of times, if you have the same answer 1 time, 3 times, what's it going to do at the x-axis? Is it going to touch and turn, or is it going to go through? it's going to go through. If you have it, if the same number 2 times, the same number 4 times, that's going to touch and turn. So here, this is all you have to do. For action at the x-axis, say goes through. This one's going to do what? Go through. This one's going to do what? Go through. You don't have to worry about writing everything on the line. You're telling me in kind of like a flow chart what's happening dependent upon all of your zeros. Yeah, if you want to write on the line, you can. Yep.
If we had to write on the line and say 6 had multiplicity twice, would we say it touches and turn, and then for the other one, say it goes through? Okay.
Yep. If you have multiplicity for one of them, like say you had 6 2 times, and then the other ones you only have once. So you would tell me at 6 it's going to touch and turn, but at the other ones it's going to go through. That's why I think it's easy to just kind of point to each one and tell me what each one does. Now, if you guys are going to graph this, think about graphing, okay? What did you tell me the end behaviors were? What did you guys gave yourself a picture at the beginning? What are the end behaviors? They're both going up. So just draw 2 little up arrows over here. What's the next thing you have to put on your graph? The x-intercepts. Where does this thing cross the x-axis? At 0, okay. So 0, put one here at 6. And then positive and negative square root of 2. Do you guys know exactly where the square root of 2 is? No, but do you know that the positive one is on the right side of 0 and it's smaller than the whole number 6? Yeah, so you can say that's square root of 2. Do you know that negative root 2 is on the left-hand side of 0? Yes? That's all I need to see. I don't need to see tick marks in between, blah, 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 blah. It's fine. Just a general sketch is all I need. Now, what did you tell me happens at each one of these points? It goes through. So just draw a little sketch here. I'm going to start over here with my up arrow, and it's going to go through this, and then do what? Go back and go through this one, then go back and go through this one, then go back and go through this one. If you had multiplicity, if you had the same answer 2 times, instead of going through, it would touch that point and then bounce the other direction, like bounce back up, or touch and bounce back down. No, no imaginaries. No imaginaries tomorrow. Everything's going to be real. All right. Do I have anything else on this page? Okay, good. All right. Another question that you are going to see is going to say, use long division. Yes, you have to use long division on one of these problems. So I'm going to go through an example again with you. Again, if this is just not clicking with you, you can come see me after school today. You can come in the morning for a minute, but do this question last. If this is just totally throwing you off, do this one last. 3x minus 4 is going to go on the outside, correct? 3x minus 4. I'm doing the one in the highlighted one. And then I have 12x. 12x, what is it, cubed? Minus 10x squared. Minus 17x plus 12. You guys are welcome to my color pencils. Try to be as organized as possible. We're going to go first term into first term. I like to go, just give myself a little visual. 3x times what gives me 12x cubed? 4x squared. So I'm going to put it above my x squared to stay organized, and I like to get my subtraction ready before I multiply. Because I have to remember to do what with that negative sign? Distribute. Okay, so let's multiply. 4x times 4x squared times 3x is 12x cubed. 4x squared times negative 4 is minus 16x squared, correct? Now, before we subtract, what do I do with that negative? Distribute. So we're going to change. Now you can combine. Negative 10 plus 16. 6x squared. Positive 12x cubed, negative 12x cubed. Cancels. And then what do I do with negative 17x? Bring it down. Guys, tomorrow, I promise you, you will not get any fractions within this problem. Like here, say how 3 goes into 6. You're not going to get to where it has to go in a fractional amount of times. So if you get 3 and you're trying to divide it into 7, you did something wrong. You forgot to distribute a negative or something, but everything tomorrow works out with pretty whole numbers for the long division. So let's do this next step. First term into first term. So 3x times what gives me 6x squared? 2x. Positive 2x. Get your subtraction ready before you multiply. 2x times 3x is 6x squared. 2x times negative 4 is minus 8x. Now, what I just said to you guys, if you forget to distribute, if you were to combine now, you'd tell me negative 17 and negative 8 gives me negative 25, right? Then when you go 3 into negative 25, you're like, it doesn't work. That should be an indication of, oh, wait, I think I forgot. I missed something, because it should all work out nice and pretty. So we're going to go through here and distribute this negative. Change, change, change. So now what's negative 17 and a positive 8? Negative 9x. Good. What happens to your 6x squareds? They cancel. And then what do I do with plus 12? You bring it down. And now we're going to go first term into first term. 3x times what gives me negative 9x? Negative 3. Perfect. Get your subtraction ready before you multiply. And then say negative 3 times 3 is negative 9x. Negative 3 times negative 4 is positive 12. And before I combine, what do? I'm going to distribute. So change, change, change. What's a positive 12 and a negative 12? What's a negative 9x, positive 9x? What does this one not have? A remainder. Okay, so your answer is just right here. You can leave it right up there. Just circle it. If you had a remainder, if it was positive, you'd put a plus sign and then put it over what? The 3x minus 4. If it was negative, you'd put a minus sign and you'd put it over what? 3x minus 4. All right? I know that's a pain. Say it again. Same exact way. Negative 4x minus 3 on the outside, and then the whole big polynomial on the other side. It's just written a little differently. All right, let's look at this one. Synthetic division. Does that mean you have to do long division? No, use the shortcut. And it says use the remainder theorem. What is the only thing we care about right now? The remainder. What number am I putting up in the corner to do my synthetic division? Negative 3. Guys, this is a super easy problem. Don't mess it up by A, multiplying or adding wrong, or B, forgetting to put 0 as a placeholder. So since we're starting off with x cubed, I have 4 for my x cubed. What's my x squared? Negative 8. What's my x to the first power? Negative 4. What's my constant? 23. I saw somebody yesterday. They came to ask me a question, and this is what they did. They write up here x cubed, x squared, x constant. That's smart. To make sure all of the places are accounted for. Say I went from x cubed to a constant. Do I have to have a placeholder for x squared? God bless you. Yes. Do I have to have a placeholder for x to the first power? Yes. Make sure of that. But how do we synthetically divide? We bring down our first term, multiply to the corner, and add down. So 4 times negative 3, negative 12. What's negative 8, negative 12? Negative 20, okay? Negative 20 times negative 3, 60. Negative 4 times 60, 56. 56 times negative 3. If you don't know it right at the top, whatever, watch, guys. Everybody in here can do this. 6 times 3 is 8. Carry the 1. Negative 168. Good. And then we add down. What's negative 168 plus 23? 5. Is it negative 145? Okay. So how do I answer this question? F of negative 3 equals negative 145. You will absolutely have a question like that. That's a gimme. Do you understand what it means by use the remainder theorem? So do you understand how to answer? Just use synthetic division. You guys can all handle it. Question, Dana, you good? Anybody have questions? You okay? All right, we're on. Use synthetic division to find the roots given. Okay, so they're giving you a root here. It says to use synthetic division. What do I do with the number they gave me? I'm going to put it in the corner. I'm going to use synthetic division to find all the other roots. Guys, what do you notice about this problem? It's not in standard form. If you write it out exactly like it is, you will get this wrong because you don't have the coefficients right. Rewrite it as x cubed plus 3x squared minus 4x minus 12. I understand some of you are going to be like, oh, well, we can factor that. That's great. What do the directions say to do? Use synthetic division. So the first thing I'm going to do is take the 0 that they gave me, x equals negative 3. Go with my coefficients. I have 1, 3, negative 4, negative 12. How many answers should I have for this problem? How many zeros are there? There's 3. They gave me one of them, so I'm going to discover the other 2. So synthetically divide 1 times negative 3, negative 3. What's 3 minus 3? 0, okay. 0 times negative 3, 0. Negative 4 and 0 is negative 4. What's negative 4 times negative 3? 12. Negative 12, positive 12 is? So what did you guys just prove? Negative 3 is a root. So x equals, we already knew that, negative 3, but you guys proved it. Now what is left over here, guys? This is x squared. I don't have anything for x, so I have minus 4 equals 0. Can you factor that? Difference of squares. X plus 2x minus 2. So what are my other two answers? X equals positive 2 and negative 2. When you're given a root and it says find the rest of them, guys, you will be able to factor whatever's left over. All right, last one, and then you guys are unbelievably prepared for your quiz. Find all the roots, use the rational root test. That's our P over Q. You might have a number like 48 at the end. You might have 60. That does not mean you're going to have to do synthetic division with every single number that's in that list. You might have to do it with 1 and negative 1, 2 and negative 2, but after that, one of the roots should present themselves. But we can't factor this. We can't put it into groups. We can't do anything like that. But we do know there's how many answers here? There's 4. So list out the factors of the last term. This actually happens to be 1, 2, and 4. This one's pretty simple. It's pretty straightforward. But I'm going to put my 1 up in the corner. And my coefficients are 1, 2, negative 3, negative 8, and negative 4. So when we synthetically divide, 1 times 1 is 1. 2 plus 1 is 3. 3 times 1 is 3. Negative 3 and 3 is 0. 0 times 1 is 0. Negative 8. Is this going to give me a remainder of 0? No. Okay, let's try negative 1. So I have 1, 2, negative 3, negative 8, negative 4. I've worked out every version of every quiz. Every one of these works. Don't come up and be like, I don't think this one works. Yes, it does. They all work, I promise. We'll get to a point where sometimes they don't, but right now everything's going to work. So multiply to the corner. 1 times negative 1, negative 1. 2 minus 1 is 1. 1 times negative 1 is negative 1. Negative 3, negative 1 is negative 4. Negative 4, negative 1 is 4. Negative 8 and 4 is negative 4. Negative 4 and negative 1 is 4. Negative 4 and 4 is 0. So what did you guys just prove? Yep. X equals negative 1 is one of my zeros. Don't forget about that. Don't just leave it. You have to tell me, hey, look, I found one. X equals negative 1. So what do we do? What is this left over? How do I write it? X cubed, good. Plus x squared. Minus 4x minus 4 equals 0. You can go ahead and jump to P over Q. You might have to do P over Q again, but check to see if it groups first. If it doesn't, then that sucks. You got to do it again. But all right, first 2, second 2. What can I take out of x cubed and x squared? X squared. Okay, and I'm left with x plus 1. What can I take out of negative 4x and negative 4? Minus 4, and I'm left with x plus 1. So did this group nicely? Good. Bring out your GCF, x plus 1 out in front. And what happens with x squared and negative 4? They get their own parenthesis, right? Can I factor x squared minus 4 a little bit more? X plus 2x minus 2. So what are my other zeros? Negative 1, negative 2, and positive 2. There is multiplicity. Here, you know what? Let me show you how you would graph this. That's a good point. We have multiplicity, right? You have x equals negative 1 2 times. Then we have x equals negative 2 and x equals positive 2, right? What are the end behaviors of this graph? Rising left and rising right. It's a positive, even exponent. So it's going up in both directions. Good. What's going to happen at negative 2 and positive 2? It's going to go through the x-axis. What's going to happen here at negative 1? It's going to bounce. It's going to touch and turn. So watch what that looks like, guys. So I have an intercept here at negative 1. I have negative 2, and I have positive 2, right? So my graph is going to come down. Well, it should be, let me do it out here a little more. So it's going to come down through negative 2. Then when it gets to negative 1, is it going to go through? No, it bounces, goes the other direction, and then comes back up through. Do you see how it bounced there? That's what the bouncing looks like, rather than touching and turn, or rather than going through. So it went through the x-axis at these two, and it bounced off the x-axis there. Yeah, that's fine.